In this video, we're going to go over the following piecewise function and determine if they're continuous or not in the interval negative infinity to infinity. So in part 1, we're told f of x is equal to x plus 7 when x is less than or equal to 1, and 8 plus 6 ln x when x is greater than 1. So here, in part 1, all we have to do is plug in 1 into x plus 7 and see what that equals, because we have this equal sign here, which means we're allowed to just directly plug in. Now for this one, we do not see an equal sign, so technically you should use limit notation instead, and this one would be approaching 1 from the right. And how do I know it's 1 from the right? Just draw a number line. If we're saying that x has to be greater than 1, we can say that 1's over here, right? And then we're going to have some huge number infinity over here. The only way for me to approach 1 is from the right. So that's what we're going to do here. So we can say that f at 1 is equal to 1 plus 7, which is equal to 8. And we can also say that the limit as x approaches 1 from the right of 8 plus 6 ln x is equal to 8 plus 6 ln 1. And ln 1 is just equal to 0. And so this is just equal to 8. And then we can see that f at 1 is equal to the limit as x approaches 1 from the right. And so therefore, we say that f at 1 is equal to 8. And so this is indeed continuous. Now what about for this example right here in part 2? We're told g of x is equal to 7 e to the x minus 2 when x is less than 0, and 6 cos x when x is greater than or equal to 0. So once again, we're going to have to use limit notation for this one because it's not defined at 0, so you shouldn't be plugging it in directly. If this were like a short answer question, you would lose marks, but yeah. And then in this one, you can directly plug in 0 because it is defined here. So all we have to do is say that this will be the limit as x approaches 0 from the left. And how do I know it's 0 from the left? We'll just draw a number line again. If I'm saying that x has to be less than 0, let's say 0 is right over here, and then all my x values are towards this side. And so we're going to have negative infinity here. And the only way for me to approach 0 is to approach from the left side. So that's why we say 0 from the left. And so all we have to do is now plug in x equals 0 and see what happens. And then e to the 0 is just 1, so this gives us 7 minus 2, and this is equal to 5. Now what about g at 0? Well, g at 0 is going to be 6 multiplied by cos of 0. And then cos 0 is just equal to 1, and so this gives us 6. And then we can say that this is not continuous because we see that the limit as x approaches 0 from the left is not equal to g at 0. This means you have a jump discontinuity if you were to graph this on Desmos. Now in this one, we're told h of x is equal to x squared minus 4 over x squared minus 2. So this should say x minus 2. And then this is when x is not equal to 2. And then we were also told that the function is equal to 4 when x is equal to 2. So let's go ahead and do this. Once again, we need to use limit notation for this one because it is not actually defined at 2. So we can say that this is the limit as x approaches 2 of x squared minus 4 over x minus 2. And so I can go ahead and factor the numerator actually. This is going to give me x plus 2 multiplied by x minus 2 all divided by x minus 2. I then see that the x minus 2's just cancel out, leaving me with the limit as x approaches 2 of x plus 2. And so I'm going to go ahead and plug in x equals 2. Now this is going to be 2 plus 2, which is equal to 4. And so we plug in x equals 2 and it equaled 4. And we also know here our output is 4 when x is equal to 2. Therefore, we can say that this is indeed continuous.